Okay, this is redox reactions part 2. Okay, so now we talked about oxidation numbers in the first one, and now we're moving on to real reactions. Okay, so the good news is that if you can do oxidation numbers well, that is 75% of the work. And this part is really just vocab and applying some rules that are pretty easy to learn. Can be a little tricky, but the trickiest part is definitely oxidation numbers. So let's move on. So this is where we left off last time. We were assigning oxidation numbers and we were given a reaction like this and we said, oh yeah, iron, oxygen started at 0 and then they both became, or iron became +3, oxygen became -2. So now we're going to actually look at what does that mean for us. Okay? And yeah, did electrons move because charges did? So here's some vocab. Vocab number 1 is called oxidized. Remember redox, so that's the ox. Atoms that lose electrons during a chemical reaction are said to become oxidized. Okay, atoms that are oxidized become more positive. And remember, just like a cation, when you become more positive, it's because you lost electrons. So you can say their oxidation numbers are increased. They get bigger. Okay, atoms that gain electrons, so the opposite, are said to be reduced, and that's the redox part. Reduced, oxidized. Okay, atoms that are reduced will get more negative, right? They're gaining more electrons, just like negative people, and they get sadder and sadder, and they become more negative because they're gaining electrons. Okay, so you can say that their oxidation numbers are reduced, which is where the name reduced comes from. So let's actually apply that now to our situation with the reaction. Okay. Before that, here's your little mnemonic of the day to help you remember that. It's called oil rig. And if you want to, you can say in a hick accent like, Mama, I'm going to work on the oil rig. Or you can just say it normally. So oil rig, oxidation is loss of electrons. That's what oil stands for. And reduction is gain of electrons. So if something is becoming oxidized, they are losing electrons, becoming more positive. They are reducing, that means they are gaining electrons, becoming more negative. So here, let's apply it to our example reaction. Iron and oxygen becoming iron oxide. This is actually called rust. Remember, a bar of iron, let's say your new bicycle, and oxygen in the air make rust, which you don't really like on your bicycle, but that's what happens. So if you notice, iron is becoming +3. That means it's becoming more positive. That also means it's losing electrons. And what happens? Which one is lost? Oxidation is lost, right? Oil. So it means iron lost 3 electrons, so iron is oxidized. And look at oxygen. Oxygen becomes -2. More negative means it gained electrons. And what is gain? Reduction is gain. So oxygen gained 2 electrons and oxygen was reduced. So let's do another example. This is a problem you might see. Assign oxidation numbers to the atoms and identify the element oxidized and the element reduced. So here's our reaction, okay? We would say solid calcium is added to water and it yielded a solution of calcium oxide and hydrogen gas. Remember? So let's go ahead and assign oxidation numbers. So you can actually try this on your own since you know how to do this now. So pause this recording, figure out the oxidation numbers, and then press play. Okay, so here are your oxidation numbers. Calcium is 0 because it's an element by itself. Water is hydrogen, oxygen, which to stay +1 -2. Hydrogen is also an element, so it stays 0. Calcium hydroxide, when you find the oxidation numbers, is +2, -2, and +1. So now we are wanting to identify the element oxidized. So which of these elements is gaining electrons? Oh, Mr. Bell, you did it again. Oxidation is loss. So which one is losing electrons to be oxidized? So we have 0. So which one is becoming more positive over here from this side to this side? Okay, so if you see, that would be calcium. You go from 0 to +2. More positive, losing electrons. Okay? And then you also want to identify the element reduced. So let's come over here. Let me see, +1, +1, -2, -2. Aha, but +1 to 0. You see that? That means it is becoming more negative, going closer to the negative side, and it is gaining electrons. So we would say calcium lost 2 electrons is oxidized. Hydrogen gained 1 electron, and so hydrogen is reduced. Easy enough? So of course, because it was easy, we got to make it a little more complicated. So this new vocab can be a little tricky, but you just need to sort it out in your head, okay? So we have these new things called a reducing agent and an oxidizing agent, okay? And they're very related. A reducing agent is a substance, not an atom, so a whole substance like salt, NaCl. A substance that causes another substance to be reduced. So if it causes another substance to be reduced, that means it is actually oxidized. So a reducing agent contains the atom, that gets oxidized. Okay? So if you have an element that is oxidized, that makes it a reducing agent. Let me say that again. If an element is oxidized, it becomes a reducing agent. Okay, so it's opposite. So an oxidizing agent is a substance that causes another substance to be oxidized. So that means an oxidizing agent is the one that gets reduced. So again, they're flip-flopped. So you are looking for what is oxidized and what is reduced. What is oxidized is called the reducing agent, and whatever gets reduced is called the oxidizing agent. So let's apply this. Example number 5. Assign oxidation numbers. Oh, I don't want to do that. Okay, assign oxidation numbers to the atoms in the following reaction and identify the element oxidized and the element reduced, as well as the oxidizing and reducing agents. Okay, so let's tackle this. Here's our reaction. So solid iron oxide is added to carbon monoxide as a gas, and it yields solid iron and gaseous carbon dioxide. So the first step, like they told us, assign oxidation numbers. So again, you know how to do this, so pause the video, use this as an opportunity to practice and get awesome at this because it will be on your test. So pause the video and try it on your own and press play. Okay, so here are your oxidation numbers. Iron is +3, oxygen is -2, +2, -2, 0, +4, -2. Okay, so they want us to identify the element oxidized and the element reduced. So which one is oxidized? Remember, oxidation is loss. Which one is losing electrons and becoming more positive? Well, this one goes to 3 to 0. That is not more positive. Okay? -2, all the oxygens are -2, but oh, what about this? Carbon is going from 2 to 4. Is that more positive? I think so. Okay? So now let's talk about which one is reduced. Reduced means getting more negative, right? And you are gaining electrons. And so again, oxygens are all -2, saying the same, so it's not that. So let's look at iron. Iron is 3 to 0. That is losing, that is becoming more negative and gaining electrons, okay? So iron gains 3 electrons. That means he is becoming reduced. Carbon is losing 2 electrons, and that means he is being oxidized. Okay, so remember, the last part is you want the oxidizing and reducing agents. Okay, so you just look at here. Iron is being reduced, which means it's the oxidizing agent. So look at iron. Aha. Iron is in this. Iron oxide. So that means iron oxide, Fe2O3, is actually the oxidizing agent. And then carbon is being oxidized, which means carbon, look where carbon came from. Carbon came from this. So that means carbon monoxide, CO, is the reducing agent. Okay? And that's because it lost 2 electrons, so it is reducing iron oxide. Iron oxide gained 3 electrons, which means it is oxidizing carbon monoxide. Okay? A little tricky, I know, but we will practice a lot in class on Friday, and we will become the kings and queens and masters of redox, and we will blow this test out of the water. Okay? So that's the end of this video. Thank you for watching, and I will see you in class.